freue mich, heute bei STILL in Hamburg zu sein, einem führenden Produktionsstandort für Intralogistik. Für das Unternehmen STILL ist eine zuverlässige und flexible Vernetzung für automatisierte Logistikprozesse unerlässlich. Disaggregierte 5G-Campusnetze mit offenen Schnittstellen ermöglichen Interoperabilität und maßgeschneiderte Lösungen zu wirtschaftlichen Kosten. Damit unterstützen wir Unternehmen wie STILL dabei, die Digitalisierung selbstbestimmt und anpassungsfähig voranzutreiben. Gleichzeitig stärken wir die digitale Souveränität Deutschlands und Europas in diesem kritischen Bereich, denn Kommunikation ist das Rückgrat der Digitalisierung und der modernen Gesellschaft.
Ganz herzlich willkommen in Hamburg zur Abschlussveranstaltung CampusOS. Also ich wünsche uns allen eine wirklich schöne und gute Veranstaltung heute Morgen.
The CampusOS project aims to help STILL and DEMATIC make the leap into the future of smart factories. Modern robotic applications will benefit from tailored solutions enabled by open 5G technology, increasing connectivity and efficiency. This innovative approach is transforming manufacturing processes and paving the way for a smarter, more responsive industry. The need for technical communication in increasingly digitalized systems is growing. The challenge is to choose the right communication approach. Open 5G campus networks could be the answer. Let's have a look. Open and modular private 5G networks make it possible to respond specifically to the requirements of the use case. One way to operate private 5G networks cost-efficiently across multiple factory locations is via a distributed network model, which centralizes functions that can be used across multiple locations. User data remains in the factories. Complex environmental conditions create difficult propagation. The use of leaky feeder cables directly in the high bay warehouse favors radio propagation and ensures homogeneous coverage. At STILL's site in Hamburg, Fraunhofer HHI assisted with the planning, deployment, testing, and monitoring of the private 5G network. Based on use case requirements, an architecture blueprint was created and appropriate solution building blocks were selected. 2 cores were tested: Ethernet 5G provided by modular and Open 5GS provided by HHI. It was demonstrated that Open 5GS core meets the requirements as an open source solution. Node H provides the RAN for 5G SA networks. Node H software runs on cells from multiple hardware partners. These are low-cost cells based on Qualcomm SoCs. At STILL in Hamburg, indoor cells were used. At Heusenstamm, more powerful outdoor cells were used. The RAN software provides full performance in 100 MHz bandwidth, and it can be configured for the specific use case and provides full support of ORAN, QoS, and time-sensitive networking. The 5G components are used to connect industrial devices and network segments in order to serve typical industrial applications with their requirements, even in mobile, wireless devices and network segments. Using extensions for Kubernetes and the TSN-enabled network controller created in the project, application components are distributed in such a way that end-to-end latency, availability, and bandwidth can be guaranteed between them. Industrial end devices connected via 5G are also supported. Both compute and communication requirements are taken into account, and a method for system monitoring is provided. Extensive validation can ensure that the assumptions made about the performance of 5G communication systems are correct. Technical parameters can be confirmed through extensive measurements, while logical parameters can be validated through simulations. A first action is to ensure spectrum clearance and to execute interference hunting to eliminate performance robbing emissions. Site acceptance testing ensure over-the-air RF analysis, signal decoding, and end-to-end connection setup. The network is functioning properly. Very important stages are network performance, analyzing test metrics like coverage and QoS, and interactivity testing, where key factors are throughput, latency variations, and packet loss combined into a single score. Last stage describes 24/7 real-time quality monitoring using centralized data analytics dashboards based on parameters retrieved by active probes. The extent to which a 5G wireless network functions well, securely, and reliably can be checked using a series of key performance indicators. These KPIs describe the performance and, in industrial environment very important, the time behavior of the network under various radio conditions. Furthermore, the mutual influences of two 5G radio networks in the same coverage area were investigated. Such a parallel deployment of two radio networks involves considerable risks with regard to the performance of the network. The measures that can mitigate these risks were derived and documented in this campaign. The security assessment of a 5G campus network based on established security standards like ISO IEC 27001 necessitates a thorough threat and risk analysis, along with appropriate measures to safeguard the overall system's integrity. This is especially vital in O-RAN-based open 5G architectures, where components from various manufacturers are involved. Here, the security and configuration of internal interfaces are of significant importance. It is also important to ensure that the 5G system runs smoothly during operation. Meaningful monitoring should be the key to success. The knowledge gained can also be used to optimize processes and control communications on demand. RAN telemetry is a technique that provides a complete view of the performance and operations from the entire technology stack, from network-level telemetry all the way to application performance monitoring traces. RAN telemetry enables fine-grained analysis of key performance indicators by combining data from the radio access network with cross-layer in-band network telemetry. Monitoring all components of the private 5G network for errors is essential for a reliable operation. Open and modular private 5G networks have generally a wide variety of management systems, which can entail a certain degree of complexity. The openness in the form of APIs can be used to merge status information from these subsystems. Modular utilizes both properties for easy handling of private 5G networks. NOC-Lite, simplification in network operation, is an alerting and status monitoring system for private 5G networks that enables active end-to-end monitoring of all hardware and software components. To ensure a radio-based use case, sufficient and reliable spatial radio coverage is necessary. In order to monitor this, the field strength values in the relevant area are simulated and displayed from individual available measuring points collected during operations. If the coverage quality is too poor, messages are generated in a dashboard which indicate a threat to safe use case operation and, if necessary, suggest countermeasures. Depending on the use case, the parameters of the heat map and the content of the messages can be configured. Since industrial applications in IT, OT, and 5G use resources and consume services, it must be possible to collect data from all networks and evaluate them on a service-related basis. Siemens provides dashboards to enable insights into the end-to-end health of the overall system and quality of service. The recorded data can be made available to third-party systems and, for example, can be used for the automated generation of alarms. Modern and technically sophisticated applications can benefit from variable and tailored 5G systems in the future. Such communication systems are particularly welcome in intralogistics, where flexible and constantly adapting approaches are required. Let's give you a sneak preview.
in so einer Fabrikhalle mit den entsprechenden Maschinen und Anlagen so ein 5G-Campus-Netzwerk aufzubauen, alles zu integrieren, wie wir es hier haben wollten für den Use Case. Da sind schon technische Schwierigkeiten mit dabei. Aber zusammen mit den Partnern ist es uns gelungen, die technischen Schwierigkeiten zu lösen und haben dadurch halt wirklich wertvolle Erfahrungen gewinnen können.
CampusOS hat uns die Möglichkeit eröffnet, neue technologische Ansätze im Bereich der Campusnetze zu erproben, gemeinsam mit relevanten Anwendern der KION-Gruppe, der DEMATIC und STILL, den Distributed Network Manager, ein neues Netzwerkmodell für private Campusnetze zu erproben, diesen erfolgreich zu validieren und testen und auch im Bereich des Betriebs der Campusnetze als Systemintegrator eigene neue Lösungen zu entwickeln.
Und das Spannende und Faszinierende an dem CampusOS-Projekt ist, dass wir zwei Seiten haben. Auf der einen Seite die Anbieter, also Partner, die Lösungen, die Produkte, die Dinge in die Anwendung bringen wollen. Auf der anderen Seite haben wir die Anwender, die genau die Use Cases realisieren wollen. Und ich denke, das haben wir erreicht bei CampusOS.
STILL ist ja ein Intralogistikhersteller und unsere Vision für die Zukunft ist Smart Factory. Smart Factory bedingt aber extrem viel Kommunikation, weil wir hier Daten austauschen. Und diese Kommunikation kann natürlich mit WLAN gemacht werden. Sie ist aber zukunftsfähiger, wenn wir sie mit 5G tun. Und 5G ist natürlich nicht 5G. Wir haben auf der einen Seite leichte Netze, die wir hier bei CampusOS betrachtet haben, die in direkter Konkurrenz zu kommerziellen Netzen bestehen, die aber für uns als Kunden oder auch für unsere Endanwender die Möglichkeit bieten, leichte Lösungen zu kreieren, die kostengünstig sind, trotzdem performant und vor allen Dingen auch extrem transparent und safe. Also ich würde sagen, das ist der richtige Weg in die Zukunft.